morning to all. Today we have to discuss about substitution reactions. What is the substitution? That means replacement, general meaning. Okay, in chemistry, substitution reactions means in a chemical reaction, one atom replacement by another atom. So generally we have two types of substitution reactions is there. Nucleophilic substitution reaction. Nucleophilic substitution reaction. Second one, electrophilic substitution reaction. Electrophilic substitution reaction. What is the nucleophilic substitution reaction? Nucleophile means already knows electron rich center or electron density center. Nucleophile attack on the reactant. Here electrophilic substitution means electrophile attack on the reactant or substrate. Electrophile means electron deficient center. Okay, so again this nucleophilic reaction generally three types: SN1, SN2, SNI. So our need syllabus SNI does not need. So we have to discuss only about SN1 and SN2. So SN1 and SN2. What is the SN1? One means uni. SN1 means unimolecular substitution reaction. Unimolecular substitution reaction. SN2 means bimolecular substitution reaction. SN2 means bimolecular substitution reaction. Substitution reaction. Okay, unimolecular, bimolecular. Remember, nucleophilic substitution reactions, whether SN1 or SN2, takes place in presence of weak base only. That point is very, very important. So this nucleophilic substitution reaction takes place in presence of weak base only. In presence of weak base only. Okay, like aqueous KOH or aqueous NaOH. Okay, this is about the nucleophilic substitution reaction introduction. Then we have to discuss one by one. First we have to discuss SN1, then we have to discuss SN2. So remember main point, nucleophilic substitution reactions, whether SN1 or SN2, takes place in presence of weak base only, like aqueous KOH or aqueous NaOH. Then generally this nucleophilic substitution reactions takes place in haloalkanes. Generally these nucleophilic substitution reactions takes place in haloalkanes. Okay. First we have to discuss about SN1. SN1 means unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. So generally SN1 reaction takes place in tertiary and secondary haloalkanes. Okay, it is very, very less extent takes place in primary haloalkanes. That's why SN1 reaction we call generally takes place in tertiary and secondary haloalkanes. Tertiary and secondary haloalkanes. Okay, so among tertiary and secondary haloalkanes, S11 preferred for tertiary mode, tertiary greater than, secondary greater than primary. Okay, this is the SN1 reactivity order for haloalkanes. Okay, okay, we take any tertiary haloalkane taking just for understanding. This is tertiary haloalkane. Okay, its reaction in presence of aqueous KOH. In presence of aqueous KOH, it gives rise tertiary alcohol. Tertiary alcohol. Tertiary alcohol. Then byproduct of KCl. Okay, eliminated. Tertiary alcohol giving. So mechanism is very important. Mechanism. Okay. So generally SN1 reaction involves in two steps. Generally SN1 reaction involves in two steps. First one, step one, leaving group. Here chlorine is the leaving group. Leaving group eliminated. That means CH3, CH3, chlorine. Okay, first step, chlorine eliminated, minus Cl. So here tertiary carbocation formation. Tertiary carbocation formation. Okay, leaving group elimination and also carbocation, tertiary carbocation formation is the step is called rate determination step, RDS. Rate determination step. This step also called slow step. Okay, chemical kinetics already you know. Slow step only we called rate determination step. Okay, after carbocation formation, in step 2, aqueous KOH, that means base atom, CH3, CH3 plus tertiary carbocation plus base atom. So listen students here, if you are assuming methyl group attached left side, means right side vacant is there. OH minus attack on right side of the carbon. That means, so the carbon, now this carbon having two directions. One direction already methyl group attached. Next another direction vacancy is there. So okay, if for example we are assuming this direction is left direction, this direction is right direction, just assuming. If methyl group attached left direction means OH minus attack on right direction. Otherwise, if we assuming methyl group attached right direction, if methyl group attached with the carbon right direction, at that time left side vacant space is there. Left side space is there. That time OH minus attack on left side. That means here OH minus attack on carbocation. OH minus attack on carbocation. Two probabilities there. Two directions is possibility. Okay. So whether right side or left side. That we can't tell which direction OH minus attack. That's why SN1 product we taken as a 50% product. Okay, based on the OH minus attack on the carbocation. That's why 50% products formation. CH3 OH one product, otherwise CH probability is 2. Okay, OH minus attack on carbocation, probability is 2. That's why here 50%, 50% product formation in SN1 reaction. Okay, so if you observe SN1 mechanism, it involves two steps, step 1 and step 2. Step 1, leaving group eliminated while carbocation formation. That step is called slow step or RDS step. After carbocation formation, second step, nucleophile OH minus attack on carbocation. Here probable nucleophile attack on carbocation, the direction probability is two ways, whether right side or left side. That's why finally SN1 product formed as a 50% 50% products. Okay, so that's why second step is called fast step. Second step is called fast step. Right. This is the SN1 mechanism. Then okay, if we take chiral carbon, okay, CH3, C2H5, C3H7, Br. Okay, this is also tertiary haloalkane, but chiral carbon. What is the chiral carbon or chiral carbon? Chiral carbon means carbon having four different groups. So now this is the chiral carbon. Chiral carbon. Chiral carbon means carbon having four different groups. Okay, so now I am taking chiral carbon. Okay, this is also tertiary haloalkane. First step, slow step, RDS, leaving group eliminated, carbocation formation. Carbocation formation. Next step, base, weak base, OH minus attack on the carbocation. What I say? Nucleophile attack on the carbocation. Probability is 2. That means it can possible to attack on carbocation two directions, whether right side or left side. That's why your product also 50% 50% product formation. This is the fast reaction. Okay, that's why CH3, C2H5, C3H7, OH 50%. Next, CH3, C2H5, C3H7, OH. This is also 50%. Okay, when the chiral carbon we have to select as a tertiary haloalkane. Okay, when the chiral carbon we have to select as a tertiary haloalkane. Okay, 50%. Generally SN1 reaction 50% 50% product formation. In this case, if OH group or nucleophile attack right direction means this is clockwise direction. This is clockwise direction. OH group attack right side means clockwise direction. Clockwise direction. This is called dextro. Dextro. Okay. If OH group left side attach. Okay. If OH group left side attach and anti-clockwise direction. Left side attach means anti-clockwise direction. Anti-clockwise direction. This is called levo. 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 So 50% dextro product formation, 50% levo product formation. If OH group right side means dextro, if OH group left side attach means a nucleophile. Not only OH, any nucleophile. Nucleophile right side attach means dextro, clockwise direction. If nucleophile left side attach means anti-clockwise direction, levo. So, students, remember, only chiral carbon taken as a tertiary haloalkane only we call the dextro and levo. Otherwise, if tertiary haloalkane we taken as a non-chiral carbon, that time also SN1 going on, but we didn't call that is dextro and levo. Generally 50% clockwise product, 50% anti-clockwise product, that's all. But you don't call dextro and levo. So only we called as a dextro and levo when we take a chiral carbon as a tertiary haloalkane. Chiral carbon involvement only you called as dextro and levo. So here 50% dextro, 50% levo. Okay, dextro and levo combination known as 50% dextro, 50% levo combination known as racemic mixture. Racemic mixture. Okay, it is called racemic mixture. Okay, this is about the SN1 mechanism. When we take a chiral carbon as a tertiary haloalkane. Now come to point again. So in SN1 mechanism, whenever we take a chiral carbon as a tertiary haloalkane, 50% is dextro formation, 50% is levo formation. Dextro means clockwise, levo means anti-clockwise. Dextro optically active. Dextro optically active. Levo also optically active. Optically active. Okay. Then dextro plus levo. 50% dextro, 50% levo. Dextro plus levo known as, already we explained, known as racemic mixture. Known as racemic mixture. Known as racemic mixture. This racemic mixture is optically inactive. This racemic mixture is optically inactive. We call it racemization. Optically inactive. Why optical inactive means? Individually dextro optical active, individually levo optical active, but dextro levo together optically inactive. What is the reason? Because dextro means clockwise 180 degrees, levo means anti-clockwise 180 degrees. Dextro plus levo whenever combination, dextro clockwise 180 degrees, levo anti-clockwise 180 degrees. So here clockwise anti-clockwise 180 cancel. Total rotation after dextro and levo 50 equally, dextro and levo equally portioned together 180 degrees, 180 degrees. Both rotations has cancelled. Finally, racemic mixture rotation is equal to 0. Rotation equal to 0 degrees. Why 0 degrees means here dextro and levo we have take equal equal portion. Equal portion. That's why, for example, clockwise. This is 180 means leave anti-clockwise 180. So both opposite rotations cancel. One to another cancel. Finally, reciprocal mixture rotation equal to 0 degrees. Okay. This is about the dextro, levo and reciprocal mixture. Okay now. So dextro and levo individually, they are optical active only. Whenever both are together, equally together, reciprocal mixture has formed. That reciprocal mixture is optically inactive. That reciprocal mixture rotation becomes a 0. Why reciprocal mixture rotation becomes a 0 means dextro, levo equal portion now. So both rotations one to another cancel. Final rotation becomes a 0. That's why reciprocal mixture is optically inactive. Rotation becomes a 0. Then another one, in SN1 reaction, dextro and levo formation. That means dextro and levo one to another enantiomers. Important point. Dextro and levo one to another enantiomers. Okay, so that means in SN1 reaction, enantiomers has formed. Simple, just a logical question asking about. In SN1 reaction, enantiomers formation means yes, enantiomers has formed. That means dextro and levo one to another enantiomers. Enantiomers means non-superimposable mirror images. Already we discussed in organic basics chapter depthly isomers concept. Okay. Next, in SN1 reaction, rate only depends on the. Okay, generally in chemistry and chemical reaction, rate only depends on the slow step. Okay, that's why here in slow step, how many reactants involving according to mechanism? Only tertiary haloalkane involving. Only tertiary haloalkane or substrate. Only substrate involving. Tertiary or secondary? Only substrate involving. Okay, base or nucleophile does not involving. So according to mechanism, in slow step or rate determination step, substrate only participate in the slow step. That means leaving group eliminated from the substrate in slow step. That's why in slow step only substrate involving. Only substrate means mono. Mono means uni. That's why this SN1 reaction is called unimolecular. That means in slow step only one molecule of substrate involving. Okay, substrate only involves in slow step. Okay, a nucleophile or base does not involve. Okay, now that's why in SN1 reaction, rate only depends on substrate or reactant, but not depends on nucleophile. Okay, that's why only one molecule involving. That's why it is called unimolecular reaction. Okay, this is about the SN1 mechanism. Next, already we discussed SN1 reaction reactivity order. SN1 reactivity order. living group. That's why due to repulsions also compound become unstable. It can easily eliminated. So living group elimination are also iodine, bromine, chlorine and fluorine. This is about the SN1 reaction. Next one, SN2 reaction. SN2 reaction. SN2. SN2. Bimolecular substitution. Bimolecular substitution. SN2 means. Okay. Generally, SN2 reaction takes place in primary haloalkanes and secondary haloalkanes. So, generally, it takes place in primary and secondary haloalkanes. Secondary haloalkanes. Okay. Then SN2 reaction generally takes place in presence of weak base and sometimes in presence of strong base also it undergoing. Compared to SN1, SN2 in presence of strong base also it undergoing to substitution reaction. Okay. So generally reactivity order towards haloalkanes, primary, secondary, tertiary. Okay. For example, methyl chloride, primary haloalkane we taking. Okay, methyl chloride in presence of aqueous KOH, methyl alcohol formation. Right, like that also, right, no problem. Otherwise, acid, right, no problem. Okay. So this is the SN2 reaction. Then we have to discuss about mechanism. SN2 mechanism we have to discuss. Generally, SN2 reaction takes place in single step. Generally, SN2 reaction involves in one step or single step. Okay, mechanism. Okay, methyl chloride. Otherwise, for understanding easy, like that, write better. Methyl chloride in presence of base OH minus. Here, living group elimination, nucleophile atom simultaneously takes place. In SN1, one by one. In SN1, first step living group eliminated, second step nucleophile atom, SN1. But SN2, here living group elimination, nucleophile atom simultaneously takes place. Single step, only in one step it is takes place. Okay. So listen, nucleophile attack on substrate is opposite to the living group elimination. This point is very important. SN1 not needed because SN1 in first step leaving group eliminated, carbocation formation. After the next step nucleophile has attacked. That's why there is no problem. But here leaving group elimination and also nucleophile attack on the substrate simultaneously takes place. That's why a nucleophile attack on the substrate opposite to the leaving group elimination. Understand, ma? Here nucleophile attack on the substrate is opposite to the leaving group elimination. So here first transition state formation. Transition state. This is called transition state. Transition state. Okay, this is not considered as the intermediate step, just a few seconds. It takes place in few seconds. That's why we cannot consider as a intermediate step. Just transition, temporary step. Okay, next formation like that. OH. KOH means KCl takes place. This here nucleophile attack on primary halo alkane opposite to the leaving group. Here if leaving group elimination from right direction means nucleophile attack on left side direction. If just we assuming if leaving group eliminated from left side direction means nucleophile attack on primary halo alkane is right side. So whatever it is, nucleophile attack is opposite to the leaving group elimination. That's why here product opposite direction, product formation is opposite to the leaving group elimination. That's why this product is called SN2 product is called inversion product. Inversion product. Inversion meaning opposite. Inversion means opposite. So SN2 product is called inversion product. So in the name of scientist, Walden inversion product. Okay, what is the reason means nucleophile attack opposite to the leaving group elimination. That's why SN2 product is called Walden inversion. Inversion means opposite. Okay, in SN2 only takes place in single step. Okay, in single step only nucleophile attack, leaving group elimination takes place. This step only we call slow step or RDS step, rate determination step. Slow step or rate determination step we call. This is about the SN2 mechanism. So in SN2 mechanism also, leaving group elimination order is iodine, bromine, chlorine and fluorine. Iodine, bromine, chlorine and fluorine. Reactivity order towards haloalkanes, primary, secondary, tertiary, already we discussed. Next, in SN2, rate depends on both reactant and nucleophile, because in single step, in slow step only, leaving group elimination, nucleophile attack also takes place. That's why in slow step only, reactant and nucleophile both involves the reaction. That's why rate directly proportional to substrate or reactant and also nucleophile. That's why here this is called bimolecular reaction, because rate depends on both reactant and nucleophile. Here two molecules involves the reaction. Okay, two molecules involves the reaction. SN1 only reactant involving, only one species involving SN1. That's why that is unimolecular. Here two molecules involving. That's why this is the bimolecular reaction. This is about SN1 and SN2. Okay. So what are the differences between SN1 and SN2? Just somewhat common difference, somewhat 4-5 difference is there among SN1 and SN2. First one, SN1 reactivity towards haloalkane is tertiary, secondary, primary. SN2 reactivity towards haloalkanes is primary, secondary, tertiary. Next, SN1 involves in two steps. SN1 involves in two steps. SN2 involves in only one step. Only one step. In SN1 reaction, intermediate formation. Intermediate formation. That means carbocation. Carbocation formation. In SN2, transition state only formation, not intermediate formation. Transition state only formation. In SN1, product is racemic mixture, 50 equal portion of dextro and levo. Okay, so racemic mixture formation. Then SN2 inversion product formation. Okay, racemic mixture formation, inversion product formation. In SN1, rate depends only on the substrate or reactant concentration. In SN2, rate depends on reactant concentration as well as nucleophile concentration. These are the differences between SN1 and SN2. Okay, some questions we have practiced in discussion class. In discussion class, 4-5 NEET level questions we have to practice. Okay students, thank you very much.